Okay, so we're going to talk about the volume of pyramids and the volume of cones today, and then we're going to quickly introduce a few things about optimization today. Tomorrow's lesson is one of the most important lessons that you're going to learn in this unit, and it's something that it should be new to you. Okay? Well, these should not be new to you. You should have seen these before. So we're going to look at the volume of pyramids. So if you look at the pyramid has 4 triangles, right? 4 faces of triangles, and then we have the base, which is either a rectangle or a square. Okay? So the volume of the pyramid is directly related to the volume of a rectangular prism. Okay? Do you guys remember what the formula is, or can you check what the formula is for the rectangular prism? Length times width times height. Okay? So if you look at the volume of a pyramid, right, it's 1/3 the length times the width times the height. So basically, if I remove that 1/3, what does it become? The volume of the rectangular prism. Right? So remember, the volume of the rectangular prism is length times width times height. Right? The volume of a pyramid is 1/3 of that. So if I put a pyramid inside of a rectangular prism that has the same length within height, it's going to fit 1/3 of it. It's going to take 1/3 of its place. Okay? Now this is just a relation. You're not going to need it. You're not going to use it. It's just like some kind of relation that's good to know. All right? Now, the length, the width, and the height. The length and the width, they go to the length and the width of the rectangle or the square of the base, right? So that means if I'm looking at this rectangular base here, right? I have my length and I have my width, okay? The height represents the height of the actual pyramid. Okay? It's not the height of the triangle, it's the height of the actual pyramid. So it's going from the tip of the pyramid perpendicularly down to the base of the pyramid. That's not a pyramid. That's a pyramid. Okay? So if I have this pyramid right here, right? The height of the pyramid is going from the tip perpendicularly down to the bottom, to the base. Okay? So you have to be careful of the height and make sure that what's given to you is the actual height of the pyramid. Okay? Otherwise, you're going to have to find it. So are we okay with that? So let's look at this pyramid right here. And then it asks you to calculate the volume of the pyramid. So I need my length, I need my width, and I need my height. Do I have all 3 of them? Yes, right? I have my length and my width, and then that 25 centimeter, that belongs to the height of the pyramid. Okay? So it's easy plug-in. All right? So all what I have to do here is volume equal 1/3 length times width times height. So I'll write it down as 18 times 15 times 25. And all what I have to do is I have to multiply the 18, the 15, and 25 and divide by 3. And you should have 2250. And because this is a volume, I need to do. What's the unit? What will be my unit? Centimeter cube. Okay? So this is one of the easiest example that you can get because everything is given to you. You don't need to look for anything. All what you have to do is plug in. Are we okay with that? Yeah. All right. An example, so I have a pyramid and it's a rectangular base pyramid. They gave me 26, 18, and 22. What does that 22 represent? Does it represent the height of the pyramid? No. What does it represent? the slant height. The slant height, if you look right here, the slant height is actually the height of the triangle. Okay? I can't use this one as a formula. Okay? Where do I need the slant height for? For what formula? For the surface area, right? If you go back and recall the surface area lesson, you needed the slant height to find the area of the triangles. You remember that? Right? In this case, in the case of the volume, I do not need my slant height. I need the actual height of the pyramid. So I need this, right? I need to find it. Do I have it? No. So if I look at this, right, I have a triangle there, and I'm looking for this height. What can I use? Pythagorean theorem, right? I can use Pythagorean theorem because this is a right angle triangle, right? I know this side, which we call that side what? The hypotenuse. What would be my base here? Half of 28, right? Because when you're dropping this down, it's gonna cut. So if this is, the whole thing is here is 26, right? So half of 26. So I have this triangle, right? It's a right triangle. This is 13 because it's half of 26, and this is 22. I'm looking for the height, okay? So what would be my formula?
22 minus scale minus 13.
Yeah. So if I'm going to call this C and B, let's say, okay? So I have h squared equal to c squared minus b squared. Remember that the formula of the Pythagorean theorem is a squared plus b squared equals c squared, where c is your hypotenuse, right? So if you are given the hypotenuse and you're looking for one of the legs, right, you're going to have to bring one over and becomes a subtraction, okay? This is the common mistake that students forget, and they tend to use the Pythagorean theorem as is, even though they're looking for one of the sides instead of the hypotenuse. Okay? So, h squared equal to 22 squared minus 13 squared. So that gives me 315. And then I'm looking for just h, so I have to square root 315, which gives me 17.7. Okay? Are we okay with this so far? All right. So now I have all the information that I need. I have the length, I have the width, I have the height. Right? Because the length and the width are the length and the width of my rectangle that I have my base. So I can just plug in into the formula. And my answer is 2,761. And then my unit is centimeter cube. Easy? Excellent. Any questions about this so far?